really quite a bit of people that we are doing here in order to make everything work in the right way. So yes, or today in the early morning we have recorded in the Egyptian National Seismological Network stations, we have recorded this nice event. If I'm saying nice event, this means that this gives us a chance to also to understand what's going on in the area, not only in Egypt but also in the regional scale. So the point is, now I would like to say not only about the recording and the location of the event, but also try to give a general overview to the specific or to the expertise and also to the public people to understand a bit our efforts to try to play a bit around with the seismic hazard assessment, and also because locating seismic events, it also has the advantage not only to know where the seismic zones are, but also to try to understand the nature of our planet. And so if I'm going through the presentation here, just try to formulate a bit a couple of questions that we would like also to understand with our Greek colleagues. And the Eastern Mediterranean itself is really nice, I would say, a very nice place to understand several tectonic processes, not only locally but regional scale tectonics. And the idea here is that the Mediterranean is or can act like a natural laboratory to understand several processes. For example, what I'm showing here, this is a tectonic map that you show the Arabian plate, the African plate, and the Eurasian plate, and the interaction between these plates are accommodated within the Mediterranean. And also very interestingly, we see the formation of back arc basins, the subduction of oceanic lithosphere, also the continent collisions. So I would like also to give an Arabic summary at the end for the others who are not really understanding English. So very quickly, to understand the GPS velocities here, what you see here, this is the measurements from the GPS measurement you see already here on counter-clockwise rotation, and you see the rate of measurements that is increasing towards the west. And that means that the rate of motion of the African plate towards the Eurasian plate is very small, and we have a very large rate here for the subduction. That means that what we see in the Mediterranean is not related to the motion of the plates, but it's more or less related to the subduction of processes that are going here, on here. So the Greek colleagues have also made quite a bit of efforts to monitor the seismicity, and there are quite a bit of temporal networks that are available there that people can also use in their purposes. And in 2018, Buchini et al., who is a collaboration with our colleagues also in Germany, they tried to understand the seismicity in this area. And not only about Cyprus or Crete, but also in the transition from Cyprus to Crete, and try to use only the IEC catalog, which is the International Seismological Center catalog, between 1964 and 2014, and try to understand what's going on. And this is because simply we wanted to go through this point a bit behind in order to relate what's going on the surface and what the people are feeling with the lithospheric dynamics, because this cannot be separated from each other. Here, something that is related to the earthquakes that is occurred here, I would like to show a couple of profiles. Exactly, if you look at profile 3 and profile 5, you see that the subduction is going downwards and can be outlined down to, you see, this is the lower seismic zone, this is the lower boundary of the seismic zone, and yes, exactly here along profile 3. And also we can see the transition here, there is some kind of a slant here, and this is what causes seismicity in this area. So there are quite a bit of attention that has to be paid here. So in order not to go into technical details, because we have really public people here, I would like to show maybe the main features. And the people here try to separate the different parts of the subduction zone here in the Hellenic subduction zone, and also the eastern part of the Hellenic subduction zone, and that is separated from the Cyprus subduction zone by a slat here. and the propagation of the slab tear has been also defined not very well, and this is because taking into account the location of these seismic events needs to be redone based on a new tectonic models, let's say it like that. And based on this identification, they try to look at the large earthquakes that occurred in the area, and you see here each earthquake is defined by the year that has been occurred in. And there are some kind of isolines where you see here the propagation of the subduction zone. Here we have the Mediterranean ridge, and then this is depth lines or depth isolines along the subduction, and you see how it's propagating towards the northeast. Seismicity can not only help to understand the situation here, and we need some seismic tomography or imaging techniques that can use this large amount of data, not only from the Greek, but from all the surroundings, from our side here in Egypt. We have quite a bit of a station, and I was really impressed of how nice the recordings of the Egyptian stations that can help really to understand not only the local tectonics, but also the regional scale tectonics, and to relate that to what can be used to help our environment to understand the different tectonic issues that cause earthquakes and for sure seismic hazards. So in order to look at the deeper part of the seismicity, so what I wanted to show here is that the tomography has been used, but not really with a very high resolution that can be used to take the seismicity a bit behind. So here we try to use the Egyptian seismic network with the available seismic stations within the area in this eastern Mediterranean, and we found that with our recordings we can increase a bit the resolution, and we did some seismic tomographic studies in the last couple of years, and this is indeed needed because we need to understand the driving forces, the plate motions, and how they interact with each other. We would like also to resolve the geometry of the subducting slabs. We are aiming to understand how the spatial distribution of these small-scale subducting slabs are interacting with each other that cause the harm to the people who are living in these areas. So we did seismic tomography, and we calculated a 3D model down to 350 kilometers, and we show here about 100 kilometer depth map, and on top of it you see the seismicity that I was showing previously, and you see very nicely here that the subduction zone is well outlined down to 200 kilometer depth that is separated from the unsubducted part of the African lithosphere. And we try to identify the geometry and the transition from continent to oceans, and also we took into account the velocity or the variation in the seafloor topography, and we related that to the age of the oceanic lithosphere that is subducting here in the Aegean and also beneath Cyprus. And it's still a very big question here that how it's going about. What about the tear beneath the western part of the subduction in Cyprus, and the Sparta angle, and how it's propagating towards the northeast? And we figured out that the subduction here in Antalya is, we can call it Western Cyprus or Antalya, and this can give the indication of a separation between two subduction zones. One is moving towards the northeast here, the other one, which is the eastern part of the Hellenic subduction zone, that is subducting towards the northwest, and we have here the Hellenites. I will not talk too much about that, but I would like just to show one vertical cross-section through the 3D model, from which we can identify the subducting slab, and because of the high resolution tomography that we perform, we were able to see the subduction of Antalya down to 300 kilometers. And what we see here, can the seismicity go down to which depth? So the seismicity in Antalya goes down to 200 kilometers, but what about the deeper part? And what is going on here in terms of their interaction between the asthenosphere and the subducting lithosphere. So there are quite a bit of open questions that we would like to discuss with you, our Greek colleagues, and that can open really or maybe under the umbrella of the cooperation between the different institutions, we can try to solve this open question and increase our collaboration a bit. Yes, so I would like to stop here and try to give an Arabic summary to our journalists. شكرا جزيلا للدكتور جاد والدكتور محمد على التقديم، وانا كنت حابب بس ادي فكره لزملائنا عن جهود الشبكه القوميه للزلازل والمعهد القومي للبحوث الفلكيه برئاسه الدكتور جاد القاضي ورئاسه الدكتور شريف الهادي رئيس قسم الزلازل، ودكتور سيد شعبان رئيس معمل الشبكه القوميه للزلازل، عن الجهود اللي بتعملها الشبكه لدراسه الوضع السيسمي او الزلازل اللي بتحصل في المنطقه، أهمية إن إحنا بندرس الجوانب المختلفة ليها بطرق متقدمة جدا، ونحاول نفهم إيه العلاقة ما بين اللي بيحصل على سطح الأرض واللي بيحصل وديناميكية الجزء العميق في الألواح التكتونية اللي إحنا عايشين عليها. معروف إنه في جزء من الألواح التكتونية دي بتتحرك باتجاه بعضها نتيجة عوامل مختلفة، بيتم قياس الحركة من لوح تكتوني إلى اللوح التكتوني الآخر باستخدام الأجهزة الحديثة اللي المعهد حقيقة عنده كمية من الأجهزة أنا يعني أثارت إعجابي، لأن أنا كنت الفترة اللي فاتت مش متواجد في مصر، ولما رجعت لقيت يعني قاعدة مهمة جدا لأي باحث إن هو يقدر يطور ويشتغل ويفيد المجتمع بشكل أو آخر. وإحنا هنا بنحاول بعد دراسة السيسميستي نقدر نستخدمها في دراسات متقدمة، بنعمل عملية تصوير ثلاثي الأبعاد للمنطقة، مش بس إن إحنا نوقع الزلازل، والهدف من التصوير ثلاثي الأبعاد هو إن إحنا نكون قادرين نشوف التفاصيل التفاصيل المختلفة للجزء اللي إحنا بنعيش عليه القشرة الأرضية والوشاح، لأنه ده الجزء اللي بيتحرك تحت ما يسمى بالأسينوسفير، والحركات ما بين هذه الألواح التكتونية هي أساس ما يدور على سطح الأرض، ودي نقدر نستخدمها في عملية تقليل الأضرار الناتجة عن الظواهر الطبيعية زي البراكين زي الزلازل والتسونامي. ويمكن حضراتكم في الفترات اللي فاتت كنتوا سمعتوا عن أحداث كبيرة أو زلازل كبيرة عن المنطقة دي، وبرضه أحب أشير إنه المنطقة دي بطبيعتها نشطة زلزاليا بشكل كبير جدا. يعني لما بنقول زلزال بيحصل 6 بنحس بيه، لكن هل الدمج بتاعه ده بيأثر بقد إيه؟ إحنا عندنا هنا ناس خبراء في المجال بتاع السايزميك هازارد أو عملية تقليل الأضرار الناجمة عن حدوث الزلازل أو الأشياء الطبيعية اللي بتحصل سواء تكتونيا أو الإنسان بيكون له دور فيها. وبنحاول بقدر الإمكان إن إحنا نوصل صورة للناس إنه في أشياء أو زلازل بتحصل بتكون قيمتها قليلة، ممكن ما بتأثرش قوي، فطبيعي إن أنت تحس بالهزة لأن أنت حضرتك موجود في الأدوار العليا، لأنه لما بيحصل زلزال بتبتدي تنتشر الموجة بتاعته عن طريق الأرض، بيسموه الجيومتريكال سبريدنج أو الويف بروباجيشن بتاعه، اللي بيختلف من موجة للتانية، كل موجة لها طبيعة مختلفة، فبناء عليه الريسبونس أو الاستجابة الصخور الأرضية اللي احنا عايشين عليها للموجات المختلفة ممكن حضرتك تحس بيه بشكل أو آخر. بنطلع بيانات بشكل مستمر ان احنا نطمن الناس، ولما بيكون في شيء بنحاول نعمل سيرفي او مع زملائنا ان احنا ننزل ونشوف اراء الناس وايه الناس اللي حست بيه، ونقدر نطور المقاييس اللي نقدر نستخدمها عشان نقدر نقول انه هنا في مشكله او ايه اللي ممكن الدوله تبتدي بيه علشان خاطر تامن حياه الناس، وده زي ما القياده السياسيه بتحاول تعمله في الفتره الحاليه. ويعني لو حضراتكم عندكم اي سؤال في الاتجاه ده يعني اكيد سعيد لو جاوبت عليه. شكرا جزيلا لحضراتكم.